Hello everybody, getting ready to do lesson 10.2 of Geometry 1 Math Part 1. And this is 45, 45, 90 triangles. In this lesson here, we have a 34-point classwork sheet here, and then 5 points of note-taking. Here is our objective, and then here is the description of the standard. Teachers, today, here is your bell work. Multiple choice. Which of the following expressions could not be used to represent the length of the hypotenuse? And down here we have, without parentheses, give your students 4 minutes to do this. Okay, welcome back. Here is the answer for number 1. It would be D in this case here, 6 times square root of 10. We use our Pythagorean theorem. We plug in our values here. We come up with this. So it'll be a square root of 104. And then you break this down. And it becomes 2 times the square root of 26. So that would be this. That would be this. About 10.2 would be this. So D would be the answer here. And then for number 2, x plus x. We just multiply through by our negative 1 here through our parentheses, so we get this expression here. X plus 6, combine like terms, we get x plus 6. A right triangle with measures of 45, 45, 90 is called a 45, 45, 90 triangle. We've got 90 here, 45, 45. You can use the Pythagorean theorem to find the length of the hypotenuse of any 45, 45, 90. Here is the situation here, 2 and 2, so we come up with our hypot of being 2 times square root of 2. This is classwork sheet 1. And then for this situation here, we have different lengths here of sides. What do we get here? 3 times square root of 2. So side times the square root of 2 would be your hypotenuse, yes? Same thing here, 4 times square root of 2. Side times square root of 2 would be your hypotenuse. Theorem 10.1, 45, 45, 90. The length of the hypotenuse is a leg times square root of 2. And symbols, so here will be your symbols. Hypotenuse equals leg times square root of 2, x times square root of 2 on that 45, 45, 90. Example 1, find a hypotenuse length. We have a situation here. So what's x? 45, 45, 90. So we just the rule we've just learned here to find what x is in this case. Leg times square root of 2, 3 times square root of 2, so it'll be 3 times square root of 2 would equal x here. Okay, our first guide practice, find hypotenuse lengths. Find the length of the hypotenuse in this 45, 45, 90. Students, this is yours down here. Teachers, give your students about 4 minutes, 3 minutes to do this one. Okay, welcome back. Here are your solutions here. It'd be leg times square root of 2, square root of 3 times square root of 2 would be square root of 6 for x. And then down here be 8 times square root of 2. And then students, in your own words, define 45, 45, 90. We got example 2 here, find a leg length. So now we're going to go from a hypotenuse now to a leg length here, 45, 45, 90. And remember the theorem about that. Hypotenuse is a leg 2. So in this case, we're going to go backwards here. Hypotenuse equals leg times square root of 2. So we have x times square root of 2. So what would x equal? Divide through by square root of 2 both sides. X would equal 7. So in this case here, your x would equal 7 here. Okay, our next guide practice, find a hypotenuse and leg lengths. So we have a hypot here, and then we have a leg. And then we have the same thing here, a hypot and a leg. So how do we go about finding that? Students, give you 4 minutes to find these out. Okay, welcome back here with our solutions. Hypotenuse equals leg times square root of 2. So we know our hypotenuse, 6 times square root of 2 equals x times square root of 2, yes? So to find x is what we're after here. We divide through again by square root of 2, and we get 6 equals x, so that would be 6, and this would be 6. Down here, same thing. hypot equals leg times square root of 2. We know our hypotenuse, and so we need to find the length of x here. So we divide through by square root of 2, 3 equals x here. That was 10.2 part 1. Part 2, part 3, email me here. And for everything else as well, thank you very much.